Okay, so in this lesson what we're going to look at, since we just talked about how we write formulas with two elements, sometimes we have a special thing in our formula called a polyatomic ion. And we have to write the formulas that contain polyatomic ions just slightly differently than we would write a regular formula with only two elements. Polyatomic ions, let's talk about them a little bit. They are atoms that bond sometimes, but they don't get all of the electrons that they need. And the first example I'm going to show to you is the example of binding a single hydrogen with a single oxygen. Just make sure my pen, yep. Okay, so if I think of hydrogen, it has one valence electron. And if I think of my oxygen, it has 6. Okay, and remember, since they are covalent, they want to share. So what's going to happen is I'm going to get a sharing of these electrons. And that makes my hydrogen stable, but my oxygen needs another electron in order to bond. Or in order to be stable, not to bond. So what happens is that these compounds sometimes will be stable, but what happens is they will actually pick up an extra electron so that they fill their outer shell. Now this can be 1 electron, 2 electrons, this can be actually losing an electron. So looking again at our example here with hydrogen and oxygen, right, we said that they shared here. And what happens is oxygen actually picks up 1 more electron so that it is now stable with 8. Now if you think about it, if I gain an electron, just like with my ionic compounds, I actually, the whole group here gains a -1 charge. If you look at the blue reference folder that I have given to you, you'll see that this is actually the polyatomic ion hydroxide. And what it's important to remember is we have this covalent bond here between the hydrogen and the oxygen, the two nonmetals. But because in this case it picks up that extra single electron, the whole group gains a -1 charge. Let's see if I can draw another example here. So let's do carbonate. If you look at your list, it is CO3 with a -2. So I'm going to have my carbon, and I'm going to have 3 oxygens. Carbon has 4 valence electrons, and each of my oxygens has 6. So now we are going to share, 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 and share. So what the result is that the carbon is stable. 1, 2, 3, 4, 5, 6, 7, 8. It is stable. This oxygen is also stable. Okay? The 2 here, 4, and then the ones in the red circles, 5, 6, 7, 8. Okay? But if I look at the other 2 oxygens, this electron doesn't have a partner, and that electron does not have a partner. So in order to become stable, this grouping of all of these atoms picks up 1 electron here and 1 electron here. The 2 oxygens that needed those extra 2 electrons, they are too far apart to actually bond with each other. We would not form a covalent bond between those 2. They have to pick up 2 extra electrons. So now this whole group now has a -2 charge. Now I'm not going to show you any others really, just because they're either very similar or they get very, very complex very, very quickly. But that's what a polyatomic ion is. Okay, so what happens is then we get an ion that acts just like one of our single element ions. They bond with something else in order to become electrically stable. So for instance, going back to our hydroxide, it would actually bond with calcium to make a stable compound that is neutral. So how do I actually write these formulas? With our polyatomic ions, we're going to use the same crisscross method as before, but when we need multiples of the ion, we have to use brackets. Okay, remember that polyatomic ion is a charged grouping ion made up of more than one element. And here are some examples. NO3 with a -1 charge, that is nitrate. SO4 with a -2 charge, that is sulfate. CO3 with a -2 charge, that is carbonate, and PO4 with a -3 charge, that is phosphate. So let's run through an example here. We're going to take magnesium, and if we remember magnesium from before, its oxidation number is +2. We're going to use nitrate, and if you look at that blue folder on the list on the back of the periodic table, nitrate's oxidation number or charge that it carries is a -1. So we're still going to crisscross these. Let's start with the nitrate because that one's easier. We're going to take that 1 and it will drop down and become the subscript for magnesium. But remember, with ones we don't have to write that, so I'm actually going to take that away. Okay, the -1 charge goes away. Now the 2 on the magnesium means that I need 2 of the nitrate, so it is still going to drop down and become a subscript. But in order to show that I need 2 of everything, okay, I can't just leave that there. And I wouldn't make that a 6 because I also need 2 of the nitrogens as well. I need 2 of these guys as a whole group. Remember, those oxygens are connected to that nitrogen. So to do that, I have to put brackets. Now I drew these as square brackets, but you can definitely do them as parentheses. Now what I want you to do is I want you to actually flip over your writing formulas practice packet to the very back page, kind of like the back cover. And we're going to do a few off of there. Okay, so in the first box here, we're going to take chlorine and cobalt, that's CO with a little o, and we're just going to crisscross them. Okay, so we're going to bring over the cobalt first into the box. And if I look at the chlorine, remember this negative, single negative, means that there is a -1 charge. So I only need 1 cobalt. Meanwhile, that 3 becomes a subscript for my chlorine. So my formula here would be CoCl3. Let's move over to the next box over. I have cobalt and carbonate. And when I crisscross those, I need 2 cobalts and I need 3 of the carbonate. So this is where I have to do my brackets. So I put brackets around my CO3 and put my subscript of 3. Now I'm going to cross my cobalt with my hydroxide. Now, for whatever reason, students seem to have the hardest time remembering to put brackets around the hydroxide. Remember that OH2 is very different than OH in parentheses 2. So just keep that in mind. Let me erase that out of here. Okay. So I'm going to crisscross. I need 1 cobalt and I need 3 hydroxides. Coming over to the SO4, I need 2 cobalts and 3 of my SO4s. Now when I do the crisscross first with my cobalt and my PO4, I get CO3, PO4, 3. Now, I can simplify here. I need to look at this 3 and then this number outside of the brackets. I can't look at anything inside the brackets because I don't want to change that polyatomic ion. But because these are both 3's, I can divide them both by 3. So I can actually write this as COPO4. And then the last one would be 1 cobalt and 3 of my NO3's. Okay, looking at my iron, my Fe. Okay, 1 iron and 2 chlorines. Next one over is very similar to my cobalt with my PO4. When I crisscross, I get my Fe with a 2, and I get 2 of my CO3's. I can simplify down to just FeCO3. 1 iron, 2 hydroxides. This next one is like the one before with CO3. It would simplify down to FeSO4, Fe3, PO4, 2. And then the last one here is FeNO3, 2. Okay, the last row is actually the easiest one. So we kind of started with the more complex ones. But if you look here, I do H and then a Cl, one of each. Here I need 2 H's and a CO3. So remember, if I only need one, all I do is write it. I don't have to use brackets because the subscript outside of the brackets would be a 1. Here I would have H and OH, which if you remember from balancing, is simply water. H2SO4, H3PO4, and HNO3. Now we're going to only do these 3 rows off of your chart here because I want you to have the rest to practice from. In addition, you have a homework worksheet, formulas with polyatomic ions, that you should use to actually practice this.